sit. Okay, thank you for all coming to my presentation. So I think I'm in the wrong spot. My presentation is about two new technologies, relatively new I have to say. The one is called SCTP, which is a transport layer protocol, and that started about 10 years ago. I've been told that for a protocol in that layer that's actually relatively new. And Go, which is the computer language invented by Google, or started at Google. With the main drivers behind this language is Rob Pike and Ken Thompson. So this talk is about combining these two technologies and see how that actually works. So first of all, who am I? I'm a software engineer. I live in London, and I just finished my master's at the Birkbeck University of London, a master in computer science, and my dissertation subject was SCTP and Go. Currently, I'm head of engineering at a company called MindCandy, and MindCandy creates online games for children. So when I started my dissertation, I first had to come up, of course, with a research question. And I had to play around with Go. This is like 4 years ago, 3 years ago, that Go just released. And I thought it was a really nice language, especially with my C and Java background. I thought it was quite a nice way of programming. And a friend told me about SCTP. And of course, I thought, why not combine the two? Because Go, the network library itself, supports TCP, UDP, and Unix sockets. And I thought, oh, maybe I can extend it and add SCTP to it. Just to be clear, I don't do a full implementation of the SCTP protocol in the network library itself. It is an API on top of the system calls of the relevant operating system. So why FreeBSD? Now, first of all my servers at home run FreeBSD, so quite like it. But the SCTP reference implementation is mainly done on FreeBSD. So it actually makes sense to actually use FreeBSD. Go is also used on, also has a version which runs on FreeBSD. So to start off, because not everybody is familiar with both technologies. Who is actually familiar with SCTP? Hands up. Nobody. Okay. And who is familiar with Go? And has programmed in Go? One person. Okay. Okay, so first, because I know that not many people have worked with one of them, let alone with both of them, I will first give an overview of what these technologies are. So we start off with SCTP, just a high-level, simple overview of what it is. So to actually explain it, I will constantly compare it with TCP, because it's quite similar, but also quite different to TCP. And most people are familiar with TCP, so it's a nice way of comparing. So the first thing you notice if you start programming with SCTP is that there is a concept called associations. So normally in TCP you have a socket and you connect with the client and the server to each other. With SCTP there is a little bit more going on. So if you look at the next picture, you see a typical application, client and a server, let's say it's that. And one of the first things you will notice is that within SCTP you can have multiple distinct data streams. We'll talk about that a little bit later. The second thing you will notice is that a single SCTP connection can go over multiple routes over the network. So you're not limited to one network card or network route. You can have your connections, your single connection, you can go over multiple routes. Or if one of the routes fails, you can actually automatically or manually switch over to another one. So all this together is called an association. The second thing you will notice is that if you compare it to TCP, in TCP the data is sent as a byte stream, so there are no markers to actually indicate the start of end of a specific piece of data, a message. And with SCTP, that you have these indications. It's a bit like UDP, where you also can send a message from one side to the other side. So if you compare it, so SCTP is actually kind of a crossover almost. Well, some people will not like me for saying this, but it's actually a crossover of UDP, like message-based, and TCP, reliable protocol. So another comparison you can make with SCTP is that the way the connection gets started. This is built in this way to prevent denial of service attacks. So in TCP you have a three-way handshake, SYN, resources get allocated, and then acknowledgement, and acknowledgement back, and then the connection can start. With SCTP, you first the client asks, can I start a connection? Then the server says, yeah, you can, and sends a little bit of information towards the client. The client has to echo that information, and at that point, the server starts allocating resources and then acknowledges it even further. This is like the server asking, like the client saying, hi, I'm here, and the server, is this really you? And then the client says, yes, it's me. So people would think this would be slower for the connection to start up, but in the third flag of the cookie egg, the client can already start sending data. So in that sense, it's as fast as TCP for setting up the connection. Let's have a closer look to the socket API. So again, I compare it to TCP. One of the things you immediately noticed is that a lot of things happen already within the hood in SCTP. So in TCP, if you look at the server, you see socket write, listen, accept, and then receive, send, and then close. So if you look at SCTP, you still have to do the socket, you bind, you listen, and then the accept is not needed because that happens implicitly. The same is the case at the client side. So your socket, you don't have to connect, you send the message. And the sending of the message actually implicit starts a connection on the server. And then you can go, this would be the case in an echo server, where you send a message from the client and then send the message back, and then you close the connection. So if you compare an SCTP C program with a TCP program, you have to do a little bit less work. So this was a very quick overview of SCTP. There's much more to it, but plenty of RFCs you can read. So now, a quick overview of Go. This one is Gopher. This is the official logo coming with the language. The pigeon is from the folder. So first, a quick look about variables in Go. If you look, the first thing you will notice is that the variable is declared like this. So the first line you see the var, then the name of the variable, and then the type afterwards. So this is the other way around from C. You can also do multiple on one line. And then the third one is an interesting one because that's a pointer. However, a Go pointer is not the same as a C pointer, because a Go pointer actually also has the information about the type stored. And the other difference with a C pointer is that in Go you cannot do pointer arithmetic. So that's a limitation. You see these decisions quite a lot in Go because they had the design philosophy less is more. So everything which is complicated and leads to errors they try to eliminate. So things like pointer arithmetic, or not having the type stored with your pointer, leads to a lot of errors in traditionally in C programs. And in Go, you constantly see these design decisions why they try to prevent that. It's actually quite nice because in the whole language, you constantly get steered in this direction of good and proper design. And then you go to the last line where you, for example, do an array of integers. And if you do it like this, then all the integers get initialized to 0. That's the thing. If you initialize a variable, also the first one, it also always gets set to a default value. Again, to prevent mistakes. So the next thing is a function. Gets declared like this. So the function hello, and then these are the input parameters: the name, string, count int. Again, the other way around. The type and the name. And then the interesting bit is the greeting string are error, because these are the return values. And the nice thing about Go is that you can have multiple return values. If they are already declared, like over here, the name, then you can just have a return statement like that without anything. This is enough. The variables get declared with a default value, so even if you don't set them in your code over here, they still get returned with the proper value. So, using this function goes like this. So you have greeting, comma, r, and then one thing you see over here is that Go also does type inference. So you don't have to declare these variables beforehand, because the compiler can figure out, because of he knows about the function, what types these two need to be. Saves, again, a little bit of coding. So this is how you do a function like this. And here you see the Japanese sign for horse. And it's quite an interesting one, because you can program in UTF in Go, which is unsurprisingly because Rod Pike and Ken Thompson actually invented UTF, so the whole language actually supported. In theory, you could write your whole program in Japanese. If you don't want to know about the return value, then you can just ignore it with just putting an underscore there. If you, for example, are sure that the error value will never fail. So the next step is, if you look, how structures are declared. So this is a type person with a name and an age. It's simple as that, actually. The thing which you cannot do in here is declaring the methods in this struct, because that goes outside. So if you look here, if you want to add a method to this struct, then you do it like this. You first start with function, then you say the p person, this is the struct I just I showed you, and then say hello. But this is actually, I should have added some return values here. And then the structure will actually have the say hello method. This is important for the interfaces. Let's say, so Go supports interfaces. Let's say that we have an animal interface with the method named talk. You declare a cat type. You can leave it empty if you don't have any specific variables in there. And then you do it like this, a function, and then you say the type. Then you implement the method, which is the same as here, and then it does something. And that as soon as you do that, you implicitly tell the compiler that the cat type is actually implementing the animal interface. So if you compare it with other languages, like Java, you don't have to explicitly tell that your type is implementing an interface, because that happens implicitly. The compiler figures it out for you and then knows that the type cat. So if you look a little bit further, then you have the a cat type, it talks, then you cast it to an animal, and then you still talk. So that's like a small example of an interface. And the other thing which I think is really important within Go is the concept of Go routines. Well, Go routines are actually coroutines with a C, C-O, which is already a very old concept. And it actually says that Go actually has the basic primitive for concurrency, which are Go routines. So if you have a Go routine, create Go routine, it actually runs it in the background. It doesn't run it and spawn it as a thread, but it actually just, it's kind of an event loop kind of process. It's very cheap. Spawning a Go routine is about 4K, which is, if you compare it with threads, extremely cheap. So, and the only thing you have to do to make a method you have into a Go routine is adding the word Go in front of it, and that's it. So if you look at this method, this accepts a connection, checks for the error, and then handles that connection in the message, but it throws it in the background. So it goes here, it accepts the connections, throws it, spawns a Go routine, and immediately goes back to the next one. So if you look at these Go routines or Go routines, Donald Knuth, he says that Go routines make it generally easier to understand and solve problems. Now, I've wrote quite a lot with Go already, and I have to say that the whole language with less is more and these really simple Go routines makes it actually really easy to focus on the problem you want to solve. So it's definitely worth having a look at. So there's much more to Go. We have Go is, for example, in a garbage collected language. It has first-class functions, and the arrays and slices is also very interesting, but that's kind of outside the scope of this thing. So let's have a look a bit closer to the Go network library. So because I wanted to integrate SCTP into the existing library, not just add another library to it. And then the question is, of course, how easy is that gonna be? Because the S3 protocol is actually quite different with this concept of associations and streams. So there was actually quite a good chance that actually would fit. So first, let's have a look how it works with TCP. So if you look, this is a typical client where you have a main function, you dial to a local host or to and you say we use the TCP protocol. But this is also very interesting, is defer connection closed. What you can do is you can actually, if you do something, you can actually with defer, you can say do this when you leave this method. So if your method will have multiple exit points, you can actually, you only have to put the one line in there. This prevents also a lot of mistakes. It's a bit obsolete here because this method only has, actually this one should have been in there. Anyway. Well, let's go back. So you get the connection back, and then the connection you can write something on it, and that's it. So you see, it's very, very simple, very straightforward. And let's have a look at the server. If you look at the server, you first start listening on the TCP, on the local host, check for errors, you make a buffer for a byte array, and then you go into a for loop where you accept the connection in here, and then the connection you read, and then you print it, and then you go back. And again, this is very straightforward. So this is actually the first thing what I looked at is how is TCP doing it, and I also looked how Unity is doing it and how Unix sockets are doing it. So I did a lot of kind of research by just first writing the C program, and then do the equivalent, the TCP in Go. And once I got the hang of it, of how everything worked, decided, okay, now I have to extend the Go networking library. So what I did is actually writing a typical server in Go with SCTP. So how would that look like? This is without having it implemented. So it was actually really simple, because the only thing I had to do was use net.listen packet. So the previous example you saw net.listen, which is for byte stream. Net.listen packet is for message-based thing. That method was already there, because the Unix socket is using that, of UDP. And the only thing actually which was different was putting SCTP in there. So creating this program and making this work was then the goal. And then you see the deferred message and all the same. And then over here you see the connection read from. And that's actually also exactly the same way you would do it in UDP or TCP. So quite simple. So from a high level, it seemed like it would fit really well. So, however, this is then the top layer. You have to become a bit more specific. So the read from would call a read from SCTP. This is of course where it becomes a bit more complicated. This read from SCTP, then what is actually not really correct. So this read from SCTP would have an SCTP connection type, and it would implement this specific method on that type. So in the previous example, you see this connection type is a really generic connection type, and then if you go lower into the API, it will go from a connection to a TCP connection, and then more specific, and in this case, we'll go from a connection type to an SCTP connection type. So a typical server would actually look like this, and this is then a bit more SCTP specific instead of the net.listen. I did net.listen SCTP, and then this was then the server I wanted to write and make work within Go. And there you see the listen SCTP specific one, and then you see the connection, which is an SCTP connection, and then read from SCTP message. So it's already getting a bit more specific. So with these examples in my hand, I thought, okay, so now this was like the top level view of this needs to work. What do I need to do to make this work? So then I had to figure out how Go is actually making the system calls to the operating system. So I had to go all the way to the bottom. And all the way on the bottom we find assembly. So in a lot of languages you see they have, like, for example, a network library, and then they have a little bit of C, which then does the system calls, and then it goes further. Not with Go. They don't use any C. So they have a lot of handcrafted assembly on the lowest level, which actually makes the specific system calls. So my first iteration of my work, I had a very specific SCTP system call, which had about 9 parameters, and it didn't fit into the Go system call, so I had to write my own bit of assembly to make it actually work. So that was actually the bottom layer. Halfway my dissertation, the people who were writing the SCTP specification, they updated the SCTP API, and that was not needed anymore. But it resulted in me having to start from scratch. But that's another story. So this is the lowest level. It's like a little bit of assembly. Then if you go one level up, you will see that in the syscall package, the specific directory, you will see a lot of scripts, Perl, and I think it's Perl, yeah, which actually auto-generate a lot of functions around these system calls. So, for example, if you have FreeBSD, you have the syscall master file with all the numbers and system calls. The script within the syscall library of Go downloads that file and then generates all these functions around it. So for example, the send message function, which we will talk about a little bit later, is then auto-generated. And here you see quite an interesting thing, because here you see that this system call, if you do man send message, you will see that it is actually having a pointer and some flags in there. You see that you have a pointer in there, which is a C pointer. They call it an unsafe pointer, which you can use if you actually indicate in the beginning of your file that you want to do unsafe operations. And then remember that I said that the Go pointer has the type information in there. You see that you cast it to an unsigned integer pointer, and this transforms it into a Go pointer. So there's a lot of these methods. So I had a couple of SCTP specific system calls. So what I did was adding some header files and pointers to specific files, and then run the scripts, which then run all these, create all these methods, specific methods. And then on top of it, I had to, that's also what you see, I had to write some extra methods to make this more friendly, or more Go-like, because this is actually quite raw. So, and then these methods, like say, on top of these, then I could use for the read from SCTP. So, what I had to do is, because SCTP in its newest iteration, so not all operating systems are up to date in libraries, but the latest version of FreeBSD, you see that the SCTP makes use of the send message and the receive message methods, which are really old methods from the beginning of BSD, I believe. These methods are actually quite interesting, because in these methods you can put ancillary data. And the newest version of SCTP makes quite clever use of that. What this green block is actually the data structure which is used by, in this case, send message, with the address, some data structure, some flags. But in there is room for your own piece of data. So what you can do is you can have your SCTP message, you basically wrap it into your own struct, and then that struct you wrap into in here with some extra data explaining what it does. So the send message function is actually not aware that you're doing a SCTP specific thing, but all the information in there is put in here, and then the receive message on the other hand will get this data, will look at the C message type, sees, oh, this is an SCTP thing, and then push it through to the next correct method. So if you look at the ancillary data a little bit further, then you will have, the first one is, for example, the stream ID. Remember that I talked about this distinct data streams within one socket connection. You can see which one it is by looking at the ID. Then you can set some flags. I forgot what PP ID is. You have also an association ID, because if you have one server, you can have multiple clients connect to it. So it's not like one-to-one, you can have one-to-many. And then with association ID, you can see which connection you're talking about. So this data is then put into the structure which is send message and receive message are using. So the nice thing with Go was that these send message and receive message methods, together with this data structure and the creation of that data structure, was already there. The only thing I had to program was actually the creation and encapsulation of this piece of data, of the SCTP specific things. So a lot of work I had to do was that a lot of the building blocks were already there everywhere. The only thing I had to do was actually copy-paste everything together and then make it SCTP specific. So I could also auto-generate it, the method. So I would say that for the work I had to do, 80% more or less was already there in one way or the other way. So the most time I actually spent was actually trying to figure out how Go worked internally, because there's no documentation at all about the internals of Go. So that took me quite a long time. The second bit of massive amount of work which happened was when they updated the SCTP API, and I had to start from scratch with my implementation. So if you look a little bit further, let's look at listen. So listen packets. So if you would do it in its most simple iteration, you would say listen packet, and then that is the application developer would see that, and that's it. But what happens underneath that is that you have net.listen SCTP, it becomes more SCTP specific. Then you create a socket which calls the socket and the bind system call, and then you do the syscall of the listen, and then you go to the assembly language kind of level stuff all the way down. So if you look at this, then the stuff I had to write from scratch was over here, and then I had to adjust couple of small things on this level and over there. So all in all, if I knew beforehand exactly what I needed to do, it wouldn't have been that much work. So let's have a look at the read from. Read from, the application developer could just say read from, as simple as that. And then you go like really specific, like SCTP connection type, read from SCTP. Then the syscall SCTP receive message. There was already an SCTP of a syscall receive message method, but that didn't, of course, that didn't encapsulate the ancillary data for the SCTP specific one, so I had to write my own one. And then you go further to the other things. And again, you see that most of the building blocks were there, but I still had to write quite a lot of stuff to actually make it work. So what was the conclusion of my dissertation, of my paper I wrote? It is actually, if you look at it, the whole SCTP protocol actually fits like a glove. Actually, a lot of what SCTP is doing is, it's already there. So, because it's kind of a crossover between UDP and TCP. And it's, I think it definitely fits in within the Go philosophy. Because with Go, it's like, the design philosophy is like less is more. And I noticed with SCTP that a lot of the complexity from the application layer is moved into the transport layer. A lot of people I talk to who work more in the layers underneath it, they don't like it, that the complexity is pushed down, and they say it's the wrong area of having that. But as an application developer, it's actually quite easy to have that complexity down, because you don't have to think. First of all, you don't have to think about it anymore. Secondly, everybody else who is using that protocol is doing this stuff in the same way. So they're not reinventing their own methods to, for example, find the message boundaries of the protocol. So, and I think that fits quite well with the Go philosophy. It makes it easier for application developers to achieve a specific goal or to solve a problem. However, I have to say that the implementation, which is available on Bitbucket, I will show you a couple of links. And you can run it on FreeBSD and OS X, is not complete because there are still some RFCs which, according to the people who wrote SCTP, are essential for if you want to have a proper implementation for SCTP. And these things I didn't implement. I think one is authentication. Kind of forget which ones exactly, but I can look at that if you want to know. So, just a quick demo session. I'm not going to debug it. I could do it. Okay, so let's look. So, first of all, let's hang on. Why are we with this place? So let's have a look at it and at a simple server. It's actually quite straightforward. This is just a server which does an echo of the package it receives. So the first thing you see over here, this is like the listen package. So this is actually the only SCTP specific thing in there is the SCTP string over there. Then in here you go into a for loop. Into a for loop where you create a buffer and then you read from the connection over here and then you write to the connection, and that is like a never-ending loop. So the nice thing about Go is that you can actually do the compile and running in one step by saying go run. Oh, we still have to load the driver. So the driver is actually available on as a reference implementation. If you want to run this on your Mac, you can actually go to the reference implementation. I think it's Google Code or something. And there is actually an Xcode project in there which you can just open and you can compile it. You have to put some header files in the correct place. I believe that nowadays there's also an installer which you can just install and then it just works. So if we run it now over here, so this one is now listening on the local hosts. Then we go to, clearly tested this before. So this is the client. Well, let's have first a quick look at how the client is actually working. It's the same. Oh. You see, this is more SCTP specific. In this case, I said first I resolve like to a specific SCTP address, then I do a dial to an SCTP. This comes back with an SCTP connection, and then later on, see here I defer the close, and here I actually write to the thing, and then read from it. And this loop. So if I run this, go run echo client, then let's say that this is like the first one. And you can see the server is there on the left. Now to actually demonstrate the idea of an association, we start up another client, and then it also gets received by the server over here. So well, this was just like the first step of my research, so to speak. I discovered that it is actually possible, and it fits actually quite well, the SCTP protocol, the Go network library. So what is possible for future work is to implement the extra RFCs, so that it actually becomes like a more complete RFC, more implementation extension. What is also possible is that a lot of operating systems don't support the SCTP protocol. Like Windows, not natively. There are libraries and drivers available, but SCTP also has a userland implementation of itself, which runs on top of UDP. And what I thought would be nice is to actually use this userland implementation, put it underneath Go, and then have Go and SCTP work on all the different platforms. So that's one further thing that we work on. So this is the end of my presentation. So I've got a blog, a Twitter, GitHub account. If you want to try it for yourself, you can go to Bitbucket account and download, clone the Go SCTP one locally. It works on FreeBSD and OS X. Give me an email if you have any questions. So this is it. Any questions? Well, I also will make the slides available online. Nobody a question? Okay, thank you very much.